The phenomenon of electromagnetic induction can be demonstrated by an experiment. Wind an insulated copper wire on a paper or wooden cylinder so as to form a coil in the form of a solenoid. Connect the two ends of the coil to a galvanometer and place a magnet close to it. The reading of the galvanometer is 0 when the magnet is stationary. The pointer of the galvanometer deflects towards the right when the north pole of the magnet is moved towards the solenoid. The galvanometer shows 0 reading when the motion of the magnet stops. This proves that as long as the magnet keeps moving, current flows in the solenoid. If the magnet is moved away from the solenoid, current flows in opposite direction in the solenoid. Thus, the galvanometer deflects towards the left. The left-hand rule is for the electric motors and the right-hand rule is for the generators. According to Fleming's right-hand rule, if the thumb, the forefinger, and the middle finger of right hand are stretched perpendicular to each other, then the thumb represents the direction of movement of the conductor. The forefinger represents the direction of magnetic field, and the middle finger represents the direction of the induced current.
Wind turbine use generator to transform kinetic energy into electricity. But how does generator do that? Let's find out what's happening. The physical phenomenon on which generator rely is magnetic induction. Induction in the form of voltage occurs when either a conducting coil is placed in the changing magnetic field or when the coil moves around in the magnetic field. Most wind turbines use the first approach. The mechanical force of the blade drives the rotor of the generator. This creates a rotating magnetic flux inside the stator of armature coil. However, there are different types of generators. To simplify, we will first consider a synchronous generator with just 4 magnetic poles. Permanent magnet causes a magnetic flux. Or alternatively, rotor coils can be excited with a DC power source. This is what the magnetic flux would look like for a 4-pole rotor. When an armature coil is wrapped around a rotor, the moving magnetic flux creates an alternating electromagnetic force in the coil. The electrons inside the material are disturbed by the magnetic field and are forced to move in an alternating direction. The displacement of the electron during a rotation can be plotted in a graph. This creates a sine wave pattern. Hence the name alternating current. By adding 2 more armature coil on a 120-degree angle, a 3-phase current can be generated. This is generally used for transporting electric power. The speed of alternating magnetic flux defines the frequency of the current. So, adding more poles and more RPM creates a higher electric frequency.
Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike coal or oil, this resource is totally renewed each day. So, how can we harness this incredible amount of energy, and is it possible to create a world powered entirely by wind? The basic principle of wind energy is simple. A series of sails or blades mounted around a rotor catch the wind and transform kinetic energy to electric energy. Traditional windmills use that rotational energy to green wind or pump water. But in modern wind turbine, it turns generator that creates electricity. This is the conversion from wind to electricity. And there are 3 primary factors that determine just how much energy they can produce: the size and orientation of the blade's aerodynamic design, and the amount of wind turning the rotor. Nowadays, wind sensors and computer systems automatically adjust the blades with expert precision to capture as much energy as possible. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. Made of fiberglass, these blades are strong enough to operate through rain, lightning, and blistering sunlight for over 20 years.